evening, viewer. Welcome to our Glory Globe TV. Here's a breaking news. Yes, ordinarily, planets in evolved planetary systems, such as the solar systems, follow stable orbits around their central star. However, many indications suggest that some planets might differ from their birthplace during their early evolution by migrating inward or outward. This planetary migration might also explain an observation that has puzzled researchers for several years. The relatively low number of exoplanets with sizes about twice as large as Earth, known as the radius, valley, or gap. Conversely, there are many exoplanets smaller and larger than this size. 6 years ago, a reanalysis of data from the Kepler Space Telescope revealed a shortage of exoplanets with sizes around 2 Earth radii. Explain Remo Born, an exoplanet researcher at the Max Planck Institute for Astronomy in Heidelberg. He is the lead author of the article reporting the findings outlined in the article published in Nature Astronomy. In fact, we, like other research groups, predicted based on our calculations even before this observation that such a gap must exist. Explain co-author Christophe Mordasani, a member of the National Center of Competence in Research Planets Age. He heads the Division of Space Research and Planetary Sciences at the University of Bern. This prediction originated during his tenure as a scientist at PMIA, which has been jointly researching this field with the University of Bern for many years. The most commonly suggested mechanism to explain the emergence of such a radius valley is that planets might lose a part of their original atmosphere due to the irradiation from the central star, especially volatile gases like hydrogen and helium. However, this explanation neglects the influence of planetary migration. Bern clarifies. It has been established for about 40 years that under certain conditions planets can move inward and outward through planetary systems over time. How effective this migration is and to what extent it influences the development of planetary systems impacts its contribution to forming the radius valley. Two different types of exoplanets inhabit the size ranges surrounding the gap. On one end, there are rocky planets which can be more massive than Earth and are hence called super-Earths. On the other hand, astronomers are increasingly discovering so-called sub-Neptunes, also mini-Neptunes, in distant planetary systems which are on average slightly larger than the super-Earth. However, we do not have this class of exoplanets in the solar system, Bern points out. That's why even today we are not exactly sure about their structure and composition. Still, astronomers broadly agree that these planets possess significantly more extended atmospheres than rocky planets. Consequently, understanding how these sub-Neptunes characteristics contribute to the radius gap has been uncertain. Could the gap even suggest that these two types of worlds from definitely? Based on simulation we already published in 2020, the latest result indicate the confirm that instead the evolution of sub-Neptunes after their birth significantly contributes to the observed radius valley, concludes Giulia Venturini from Geneva University. She is a member of the Planet S collaboration and led the 2020 study. In these regions of their birthplace where planets received little warming radiation from the star, the sub-Neptunes should indeed have sizes missing from the observed distribution. As these presumably icy planets migrate closer to the star, the ice thaws, eventually forming a thick water vapor atmosphere. This process results in a shift a planet ready to larger values. After all, the observation employed to measure planetary radii cannot differentiate whether the determined size is due to the solid part of the planet alone or an additional dense atmosphere. At the same time, as already suggested in the previous picture, rocky planets shrink by losing their atmosphere. Overall, both mechanisms produce a lack of planets with sizes around टू अर्थ रेडी। BS दास रिपोर्ट, ग्लोरी ग्लोब टीवी दिल्ली, भारत।